Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Syazwan bin Zakaria, and currently I'm doing master in IT as a part-time student. And my supervisor is Dr. Luman Rahim, and my co-supervisor is Dr. Muhammad Ilmi bin Hassan. So today I will present my master topic, which is migrating specific legacy open source simulation software into cloud service using architecture-driven modernization approach. So I will start with the background of the study. So I will present what are the demands for cloud computing, and next what are the advantages of the cloud computing, and following with the problem with the simulation software, and what are benefits of cloud computing, and what are the reasons to migrate into cloud service. And after that, I will introduce what is cloud migration and what are the techniques, and what is actually architecture-driven modernization, and lastly, what are the model transformation. So today, as we know, many systems and applications are starting to move from traditional physical computing system into cloud computing architecture because of the advancement of the technology in the industry. According to Gartner, the market for public cloud service is projected to have increased in 18% from 2016 up until 2017. As we can see here, from 2016 and 2020, Gartner have forecasted the market for cloud computing will be increasing across the year. So, based on my topic, so the challenge with the simulation software is it requires high computational resource to operate smoothly, and the resource requirement can be greater than initial resource requirements. So this is depending on how the complex of the system. So with this, cloud computing has the ability to provide rapid resource elasticity, which will make the cloud as high scalability of resource toward the demand. Thus, this is show that this is the best technology to be applied to a simulation software. So there are several approaches for users who want to adapt with the cloud computing technology. So first, they can rewrite, and then they can replace the system, and lastly, they can follow with migrate. And migrate is the most frequently used by the user to have their software run into the cloud service. The reason why people choose to perform cloud migration is because it will require less effort to change from traditional computing to cloud computing, as the objective of the cloud migration is to migrate the legacy architecture to cloud architecture. The target cloud architecture must achieve high functional stability. Higher the functional stability, the higher the ability for the cloud architecture to meet all the functional requirements of the legacy system. So there are several techniques in order to perform cloud migration, and one of them is architecture-driven modernization, we call it as ADM. So ADM is not only will migrate the existing simulation software to the cloud, but it's also intended to modernize the legacy software by making the software be more agile to the user. So ADM is an idea of modernizing legacy system by considering all the aspects of the legacy system architecture and the capability to evolve the legacy architecture to target architecture. So this technique can assist reverse engineering process by following model driven architecture, which is called as MDA standard, which set by object management group. These driven model standards are able to solve standardization and automation issues which happen in the traditional re-engineering processes. ADM method will utilizing of model transformation because the abstraction from MDA. So what is model transformation? Model transformation is a set of activities that perform as automated process that will have input that consists of one or more source models and will generate one or more several models as a result while ensuring the transformation rules. The model transformation is important because the migration process will take place and running depending on the model transformation developed. There are several types of model transformation that will be used along the migration process. For example, code to model, model to model, model to code. But this research is focusing on developing the model transformation of legacy model to model because this is the most important aspect in model-driven development. So moving on to my problem statement. So first, traditional computing architecture does not have the ability to scale to the demand of the legacy simulation software. Second, legacy simulation software is unable to automatically migrate into cloud service with normal migration technique. And lastly, there is no rule of standard designed to migrate simulation software into cloud with a high level of functionality of the target architecture. So my research objective is first to design the model transformation for open source simulation software migration. Second, to develop a model transformation for open source simulation software migration. And third, to evaluate the proposed model transformation. The scope for this research is first to the development of the model transformation to migrate software into cloud service. Second, the architecture-driven modernization method used to perform cloud migration. And third, migrating specific type of simulation software, which are computational fluid dynamic and partial differential equation. Next, I will present about the literature review section migration approaches. The migration approaches are selected based on certain criteria. So the approach must have the capability to migrate legacy architecture to the cloud architecture. The approach should be able to perform the migration automated or semi-automated. So these are the literature review that I have done up until these days. So first of all, from Zhang, so the approach details in this paper is they are referring to architecture-driven modernization (DM), and the legacy system is in the SAS level will be running above PAS. And type automation that they are using in this method in this paper is automated. And type of application is they are doing on oil spill contingency and response Oscar simulation software. Model transformation research, they are using model transformation. And type of migration, legacy to cloud migration. So moving on to the Flore and Flore paper. So in this paper, they are using MD as a basis of migration. They migrate from mainframe to web service, and they are performing migration principle same as ADM, but the migration start at the model of the code, and the process is automated, and they are applying on a large scale banking application. They are adapting model to model transformation to create target model transformation, and type of migration they are using is legacy to web service. So next, Ahmad and MA Baba. So in this approach, they are adapting ADM. So they also develop a migration plan phase which happened before the migration process, and this phase is not included in the original ADM framework. They are extending the traditional architecture, re-engineering and modernization model to a framework that provides process-driven solution of legacy to cloud migration. But in this approach, they are using semi-automated, which means that some of that are manually done, and type of application they are using on premise mail server to cloud-based email client. So they are using architecture mode transformation during architecture transformation process, and type of migration they are using is legacy to cloud migration. So moving on to S-Ray and W Hasselbrink. In this approach, they are calling the approach is cloud MIG approach. They are migrating to PAS and IAS. They are consist of legacy architecture and target architecture, and this process are semi-automated. And type of application they are using is existing enterprise software. They are using model transformation, and also they are perform legacy to cloud migration. Next, from the author P. Mohd and Sutter and Mohd and A.J. Vere. So in this approach, they are using baseline remix. They are using ADM as their baseline. Their approach named remix, and they are using model-driven technique. In remix, there are several phases. First phase is recover, migrate, compose and development, reservice, they validate, control and supervise. So they are actually editing, they are extending the ADM framework, which is including validate and control and supervise. So this phase is not included in original ADM method. So type of automation they are using is semi-automated. So type of application that they are applying is BI system. So this is software for enterprise resource planning, accounting, customer relationship management, and they are utilizing model-to-model transformation. The type of migration that have been done is legacy to cloud migration based on service-oriented architecture. So based on the study conducted on the existing approach, they are using model-driven approach which allow the migration process to be automated. There are differences between approach 18 and this research, which is the difference between approach 18 and this research is the focus area. So in approach 18, it's more focusing on generating web service for the target architecture, while the research is focusing on the model transformation used in modernization. None of the paper propose a software migration technique that is capable to migrate more than one software. So moving on with the scientific simulation software selection. So in this literature review section, I've done software categorization. So this software categorization is divided into several types. First, property and rights. So, and then what are the purpose and what are the type of the software, and lastly, source code language used in this in their what are the source code language that the software is using. This is important because the tool must be compatible with the language of the source code. So identifying the source code language will help this research run smooth. So you can perform the architecture extraction correctly. For example, the tool is for C++, you can use CPP to there. For Java, you can use Eclipse UML and Eclipse UML generator, and for Python, you can use py and source. So what are the criteria for selecting scientific software simulation? First of all, the software must be open source software. This is for the freedom to access to the code and reverse engineering and migration. Second, the category that has highest number of scientific simulation software. This is as indicator for this type of simulation software have a better certificate in the market, as developers want to provide their application to cater market demands. Lastly, software that has highest popularity in each category. So this is based on the search result from Google Scholar, and indicate the software is being used in the research area. So based on 44 scientific simulation software, 2 scientific simulation software are selected, which are from computational dynamics and Phoenix from partial differential equation. As we can see here, Perform get the highest number search result, which is 2640, and for Phoenix we got 155 search result. So based on this search result, Perform will be represent computational fluid dynamics and Phoenix will be represent partial differential equation. So moving on to the methodology part. So in this research, I will use the method as a baseline. So we start from the legacy source code, and with reverse engineering process, we will generate legacy architecture of the system, of the legacy system. By applying model transformation, I will generate the target architecture. So from the target architecture, we can get the target code by undergo for engineering process. So this is the research framework for this research. So first, we will start with the literature review. In this literature review, I will identify the research problem and research gap, and study and understand the current and the past research that has been done by past researcher. And then moving on with the simulation software selection. In this phase, I will identify the simulation software suitable for the experiment. So after that, I will undergo the process reverse engineering. So in this reverse engineering, this phase, the system that are selected previously will undergo the reverse engineering process. In this process, I will extract all the design and architecture of the selected simulation software. So the design model transformation. Next, we'll proceed with the design model transformation. So in this phase, we identified what are the commonality and the variability between the selected software, and mapping the legacy architecture with target architecture, which is cloud architecture, and decide what are target model and the meta model that we use in this research. Moving on to the next phase is development of model transformation. In this phase, I will develop the model transformation based on the design that I have previously done on the design phase, and select what are the suitable language tools that we will use for this research. So, and after that, I will evaluate model transformation and functional stability measurement. In this phase, I will test the model transformation that are developed previously in the development, and then create a test framework for this evaluation. So this test framework consists of 3 components. So first is test case constructor, second test case oracle, and third test case engine. So test case constructor is for generating the test cases. The test case oracle is expected output of the testing, test engine is used to run the model transformation test. So in this, so the three components will be run together in order to test the model transformation. So the concept of generalization is applied in this research in order to make the model transformation would be able to transform more than one software. Generalization can be achieved by developing a model transformation that has the modifiability attribute. So in order to create model transformation that has a modifiability attribute, the commonality and the variability analysis need to be carried out during the design phase of the model transformation. So the commonality and variability will give many advantages to developers. First, it will provide semantic way of thinking about identifying the product family, help to create a design that can be reused and easy to change, help to predict the success and the failure as the product evolves, and lastly, to identify the chances for automation for creating of family members. So by applying commonality and variability analysis in this model transformation. So as we can see here, there are first architecture of a form, and there is second, which is a second architecture, which is architecture from Phoenix. So these two will undergo probability and commonality analysis. So from this we can identify what are the variation of architecture of form, what are the similarities between architecture of form and Phoenix, and what are the variation of architecture Phoenix. And thus the result of this analysis will help us to develop the model transformation that will have the modifiability attribute. So this will cope with the different type of simulation software that we have. So then moving on with the model transformation testing. So the diagram shows that the model transformation testing phase. So basically first we have the model transformation, and then the model transformation will be tested with the test case that have been generated, and then from the result of the test case we compare and analyze with the test local. So we can see whether this test result and what we have with the test local, we can compare to see what are the errors, what are the flaws in the model transformation itself. And this test will be run by the test engine. All this process is run automated. So there are few metrics that can be used to measure quality of an architecture. So Cordero, EF, and Oliveira J. E. 2018 proposed some equation for size, coupling, and cohesion metrics. Metrics for coupling and metric for cohesions. Zhang T, Deng N, Wu Ji, Zhou Q, Masi proposed some equation metrics for measuring similarity, variability, reusability, and complexity. So these are the metrics that proposed by Zhang. So metric for similarity, metric variability, metric reusability, and metric complexity. So all the metrics will be used in order to evaluate the model transformation. So moving on with the project activities and key project milestones. So these are the project milestones, and currently in this semester I will do, by end of this semester I will do the reverse engineering and the design model transformation, and by the early of next year I will start to develop model transformation, and after that I will testing evaluate model transformation. So these are the research Gantt chart. So this is for the conclusion. So this paper represents a group of model migration approach which is related to the research. So this approach will be analyzed more critical for this research. This paper also presents research framework which is adapted from ADM framework with the addition of phase to evaluate the model transformation to ensure high functional stability. In the future, the reverse engineering phase, the design model transformation and development of the model transformation will carry out. The result of the phase will be discussed and presented in the future. So these are my references. Thank you. That's all for me.